In this video, we will be focusing on evaluating functions from a variety of equations. To evaluate a function, this is how we depict it as f of x. First thing that you are going to do is recognize the number or expression inside of the parentheses is going to be replacing x. So you want to recognize that the number inside of the parentheses, and sometimes it'll be an expression, is replacing x. Then you are going to take that and you are going to substitute the number into the function. And then finally, you are going to simplify. For some examples down here, for number 1, this is something that you may have seen before in previous classes. If not, that's okay. We are given this equation, y equals negative 3x plus 6, and it says to evaluate when x equals negative 1. So what that means is we're going to take negative 1 and we are going to substitute it in for x in the equation. Let's go ahead and keep everything the same in that equation, except we're replacing the x with negative 1. So it looks like this. Y equals negative 3 times negative 1 plus 6. It's very important that you put parentheses around what you're substituting in for x. You can type this entire thing into your calculator the way that you see it using the parentheses, and it'll give you a number, or you can work it out by hand. But I think that we should just use our calculators because it'd be very helpful considering we did the most recent calculator lesson. So when we type that in, we end up getting negative 3 times negative 1 plus 6 results in 9. Our answer for that is y equals 9. If you look at example 2, it's actually very similar to example 1. It just looks a little bit different in the original problem. Instead of saying y equals, it says f of x equals negative 3x plus 6, and we want to find f of negative 1. What that means is we're going to take negative 1, which is the number inside of the parentheses, and we are going to replace it with x. And technically, we could replace it with both of these x's just so that when we set up the original equation now, you'll be able to see what it looks like. So what we're basically saying, if we take negative 1 and put it in for x, what do we get? You could think of it as an input, and then we're going to see what we get as an output. I'll go ahead and rewrite it. F of, we're putting negative 1 in for x, equals negative 3. Again, we're putting negative 1 in for the x with parentheses, and then plus 6. You can type that in your calculator right here and see what you get. What we're doing is negative 3 times negative 1, which is positive 3, plus 6, which gives us 9 again. It's basically the same idea as problem number 1, except it looks a little bit different. So what we can say for our final answer then is f of negative 1 equals 9. When you put negative 1 in for x in the function, you get 9. Let's look at the next example. It says find f of 2 if f of x equals negative 3x squared plus 5. Let's recognize that the number inside of the parentheses is going to be substituted in for x in the function. When we do that, put parentheses around it. So f of negative 2 equals negative 3, and then we're replacing the x with negative 2 squared plus 5. Type this entire thing into your calculator the way that you see it with the parentheses, and we'll get a number. We end up getting that f of negative 2 is negative 7. Let's take a look at number 4. Number 4 is a little bit different, but this is a very good preview of what you'll be seeing a little bit more once we start solving systems of equations using the substitution method. So instead of having a number this time, it says find h of x plus 3 if h of x equals 2x plus 1. So what we're doing is we're actually substituting this entire expression, x plus 3, in for x in our equation. We're putting it into the function. So what it looks like is h of x plus 3 equals 2. And then in place of x, we're substituting in that entire expression, x plus 3. And we still have plus 1. Now we're going to use our prior knowledge that we used before when we were distributing and combining like terms on day 2. So I'm just carrying down this h of x plus 3. Don't have to do anything with that, but now we distribute the 2 and multiply it by each of the terms in the parentheses. So 2 times x gives us 2x. 2 times 3 gives us 6. So we have 2x plus 6, and then we still carry down the plus 1. And then we have these like terms to combine. 6 plus 1, that gives us 7. So we have h of x plus 3 just gets carried down equals 2x, and we said 6 plus 1 gives us positive 7, so 2x plus 7. We can't go any further with that because the 2 has an x and the 7 doesn't. They aren't like terms, so our entire answer is actually that expression 2x plus 7. Similar idea here. For this one, let's just continue with the same process that we did on the first page. It says find f of negative 5 if f of x equals negative 3x plus 7. So now we're taking that number that's inside of the parentheses, this negative 5, and wherever we see an x in the function, we're putting in now negative 5. So f of negative 5 equals 3, and then we're putting negative 5 in for x, so times negative 5 minus 7. You can type this entire thing into your calculator the way you see it with parentheses and see what we get. And we should get that f of negative 5 equals negative 22. So that is our answer for 5a. 5b says, if g of x equals x minus 9, find g of 3. Wherever we see an x in our function, we're going to replace it with 3. So the new one reads g of 3 equals, and then we're putting 3 in for x minus 9. Again, you could type that straight into your calculator, and what we're doing is 3 minus 9. We end up getting negative 6. So g of 3 equals negative 6. When we put negative 3 into that function for x, we get negative 6 as a result. So our input is positive 3, and our output is negative 6. And then this is something that you'll see again. It says, using your answers from 5a and 5b. So now we're looking back up at these answers. What is f of negative 5 plus g of 3? Well, when we did f of negative 5 in part 5a, we got negative 22. And then when we just did g of 3 in part b, we got negative 6. So we're doing negative 22 plus negative 6. And when we add those up, we get negative 28. Numbers 6 and 7 are similar to the one that we did on the front, where this time we aren't just substituting a number in for x in the function, but we're substituting this entire expression, x minus 2, in for x. So it says if f of x equals 5x minus 1, find f of x minus 2. So wherever we see an x in the original function, we're going to substitute in x minus 2, and when we do that, we're going to put parentheses around it. So f of x minus 2 equals 5, and for that x also, we're putting in x minus 2, and then we still have minus 1 there. You can carry down the f of x minus 2. We'll just keep carrying that down with the equal sign in front. But now we could distribute the 5 and multiply it by each of the terms inside of the parentheses. So 5 times x is 5x, 5 times negative 2 is negative 10, and then carry down this minus 1 on the end. F of x minus 2 equals 5x, and then we do have these like terms to combine. Negative 10 minus 1 more is negative 11. So our answer for this one comes out to be 5x minus 11. And then finally for number 7, it's that same idea. It says if g of x equals 2x plus 7, find g of x plus 6. That means wherever we see an x in the original function, we're going to substitute it with x plus 6 or replace it with an x plus 6. So g of x plus 6 this time equals 2 times, we're replacing that x with x plus 6 plus 7. Carry down the g of x plus 6 in the equal sign. And now we distribute the 2 and multiply it by each of the terms in the parentheses. 2 times x is 2x. 2 times 6 is positive 12. And then we carry down the plus 7 on the end. And then we do have these like terms to combine. They're both constants, 12 plus 7. They don't have the x's attached. So we'll combine those. But let's just carry everything down in the front from left to right. So we still have our g of x plus 6 equals our 2x gets carried down because we don't have any other terms with an x to combine it with. But we can now add those numbers together, 12 plus 7, to get positive 19. So plus 19. Our final answer for that one is 2x plus 19.